So today we're going to be going through points, lines, and planes. These are the three big building blocks to everything that we're going to cover later in geometry. In essence, a point is going to be the most fundamental building blocks. It has no dimensions. A line is a little bit better. It has one dimension, length. A plane is going to have two dimensions. I can go left, right, up, or down. So I can't come towards the camera, but what I can do is I can move around on the plane right here. So let's go ahead and see what the sketches of these things would look like. Now, if I were to sketch a point, what would a point look like? Well, a point is an indeterminate point. So really, if I were to draw a point, boom, there it is. Because it has no depth, it has no volume, it has no area. So I wouldn't actually draw it. But we're sketching. So in geometry, how do we show a point? We draw it as a point. And we label it. So point A. We're going to name it. The ways that we typically name a point is we either call them point A, or sometimes we just say A. Typically those refer to a point. Likewise, if a point has no dimensions, for a line what I'm going to need is I'm going to need more than one because I'm measuring a distance or a length. And to have a length, what I need is I need a distance between two. If this was my A, I need to have the length from A to B or some other number. And the way that we show a line is that line doesn't stop at A. It goes through A. And it goes through B. We draw arrows on the end of it to show that line continues on forever. Because if I didn't draw the arrow, that line would stop at point B and not continue further. If I didn't draw the arrow over here, you're telling me that that line stops somewhere between that point and here, but I don't know where it is. So that would just be poor form. Really what you do is you'd want to put like some point C and say, well, that's where the line stops. But our line goes on forever in both directions. The other way, if I sketch a line, is I could sketch a line through 2 points. Let's say these points aren't named. I could name the line, let's call this line N. And where we always put the name of a line is we put it near one of the arrows, because that way it doesn't get confused with the point itself. If I were to put the N right here, well, is this N or is that B? We wouldn't know. So we always put the name of a line off to the side beyond the arrow. In essence, we're putting the name beyond infinity so it never gets confused with anything else. And what do we name this? Well, I could name this line AB, or I could name this line BA. That's one way of naming a line. I could also name this line N. But more commonly what you're going to see when we name a line is we're going to name 2 points on that line, A and B. So I'd say A and B, and I'm going to draw a line over top of it. That tells me that this is line AB. But the line doesn't just go from A to B. I could start at B and go to A. So I could say BA. Perfect. And those are the ways that we typically name lines, either with 2 points with the name of it, or I show this notation where I list 2 points and just show a line above it. Next up is a plane. Now, if I'm graphing a plane, I need both length and something else, which means that if I have my points right here, A and B, I need another point that's not on this line to give myself a plane. So this just gives me left and right. If I were to rotate it a little farther, it would still be left and right, but it would be slightly left and down, slightly up and right. Doesn't change the fact that it's one dimension. I need to include something else that's not on that line, or what we call non-collinear. We're going to call that point C. And when we sketch a plane, quite literally what we do is we just draw a plane around it. And so these 3 points are inside the plane. Now what isn't shown here is that the plane always indicates that, well, this technically goes off towards infinity in every direction. We don't ever write that down though. But when we have anything inside of a boundary like this, we're saying, hey, this boundary is going off towards infinity when it's a plane. If it's some sort of finite plane, meaning it has edges, we'll tend to put some sort of reference point. We'll put it on a grid. We'll put markers right here on the edge, but because there's nothing on the edge, I'm assuming that this edge can go on forever. I have no measurement going on. Also, just like we named the line by putting it just outside of infinity, we said the edges of this plane go towards infinity, but the way we tend to name a plane is we'll put, if that's line N, let's call this plane M. We'll put the name of a plane off in a corner. So I could put the M right here. I could put it right here. I could put it right here. I tend to personally put it in the top right just because that's kind of where I would put my name on a paper. So I'm going to put the name of the plane right there. There's no reason though. You can put it in any corner that you want. Let's name this. Well, like with the line, if I say line and insert some points on that line, I can do that with a plane. I can call this plane ABC. I could also say this is plane BAC. I could name any one of those. I could also name this plane M. So I could name 3 points on it that are non-collinear. What I could not do is if I listed another point along AB and I said, let's call this point D. And I know that point D, let's do this in a different color so we don't get ourselves confused. Let's do this in purple. So if A and B were connected with a line and I put another point D here, I could not name this plane ABD because that's all along a line. That doesn't actually give the plane that other dimension. It has to be off of that line. Likewise, I could not do that same thing with A and C. I couldn't name a point between A and C and call this plane A, E, C. It's got to be off of the line. I can name it by the name. And the last thing, the notation for naming a line is by listing 2 points with a line above it. I do the same thing with a plane. I can draw a little plane notation, which is my little like rhombus or parallelogram, and I just list some points. So I'd say A, B, C. Perfect. So we have plane ABC. So those are how we sketch things. So if we're making the sketch, that's one thing, but what about interpreting somebody else's sketch? What are some common things that we're gonna keep our eyes out for? So when we look at this plane, I've got some lines, I've got some points, I've got some names that I can see. I've also got this weird dotted line thing. Now, one of the things that we see when we see a dotted line is we're assuming that there's now something that we're gonna call a three-dimensional aspect. This plane exists right here. I see that part of this line is dotted, which means part of this line is behind this plane. And now the only way that that can happen is if this plane is like a sheet of paper, and we've taken that sheet of paper and we've kind of laid it back a little bit. And what's going on with this line is I can see part of it and I can't see another part, which means that I'm piercing the plane. So just like part of my pencil, I can't see that part of the pencil. So that's the line. It's going through our plane, the three-dimensional aspect to it. So this point E is not on the plane, it's above it. This isn't a flat image. We're looking at, it's not a flat image by saying plane, line going through it. This is something that's been tilted and my line is going through my plane. So keep that in mind as we go through and answer these things. So I want to give 2 other names for line DE. So I'm going to find D and E and say, okay, this is that vertical line that's piercing the plane. What are 2 other names for it? Well, I could be sly and call it line ED. So I could call this line ED. Super sneaky. Or what I could do is I could name another point. So I could say, well, point F is along this. I could say EF or DF. Or what I could do is I could say FE or FD. I've got lots. So far I've got like 5 right now. Or what I see up here is I could call this line N. Now any of these are good. if I name 3 points that are collinear for part B? So I'm going to look over here at my drawing and try and find 3 points that are along a line. And lo and behold, look, it looks like I got those same 3 points. So I'm going to name those. I have E, D, and F. Now what I cannot do, and some of you might be noticing this, is you might, well, is there a second set of options? Well, what I do see is it looks very much like that C, D, and A could be, because I could draw that line right there. And so I'd have another set of collinear points. Now the big thing in geometry is this is a sketch. I'm not sure whether this is drawn to scale. Is C in that same orientation as A is? If it's not indicated that it's along a straight line, we don't assume that it is. It looks like it should be, but remember, a point has no depth, no width, no height, no nothing. So if that is one molecule off, it's not collinear. So I can't assume that because no matter how small the error is, you just can't do that. 4 points that are coplanar. Well, we discussed that this line is vertical, which means point E and point F are not in this plane. So the only points left, I have A, B, and C. D is along my vertical line, but it looks like it's right at the intersection, which means that D is also in my plane. So I have 4 points. I have A, B, C, and D. So part D right here, I need another name for BD. Okay. Well, there's no other points on this. I could say M, but that's the whole line. I'm not looking for line BD. I'm looking for segment BD, which means because there's no arrows, I start at B and end at D. M is the name of the line that goes on to each infinity. So I can't name it that. The only option I have is to pull that trick and say DB. It's the only name I can give it. And then E. The last one says I need to name all shown rays with endpoints of D. Okay, so a ray is where I have a starting point, and then I have a direction. So my endpoint right here is going to be my start. Terminology a little conflicting there, but I'm going to start at D, and then I'm going to go in a direction. So my options are D, well, I could go in the B direction. So let me go ahead and list that. Let's see, we haven't done green. So I could say D to B. Now if I start at D and I go through B, my ray notation is going to be a line over it with an arrow over the direction that we're going. I could say, I could go down to F, so DF. I could go up to E, so DE. Now, I could go from D to C. There's no reason why I can't, but it's not shown. So albeit the D to C and the D to A, I'm not going to put those down. And there we go. So if we look down at the bottom of this, we see that we're just kind of matching kind of what we already know. So one of the things, a line, how long is a line? Well, it's infinitely long. And it has no endpoints because it's infinitely long. In a line, we know that because it goes infinitely in both directions, it's going to be that one, which means that that is my line image. And with line segment, I do the same thing. A line segment is limited. It only has one endpoint. Nope, it has 2 endpoints. It has a start and a stop. It's going to be the thing way up here. And my bottom image. Now, a ray is of infinite length. Remember, a ray keeps going in one direction. Even though it has a starting point, it's not infinite in both directions, like a line is. A line is infinite to the left and to the right. A ray is only infinite in one direction, but it's no less infinite. One endpoint, there's my ray, and there's my ray. Perfect. That's going to bring us to the sketching. Okay. Now the sketching is a very important part of geometry. So we're going to go through a few sketches and kind of see what would they look like. How do we show this stuff? So without further ado, let's jump into the first one. We want to sketch a plane and a line that is in that plane. Okay. So I have a plane. There's my plane. I need to give it a name, M, and a line that's inside of it. So quite literally, I'm just going to put each of my infinities of my line is contained within this plane. I'll call this line L. Now I could give it some points right here, and I could say this is A and this is B, but the big thing that I don't want to show that my line is inside the plane is I do not want to put it over here. That line is not inside the plane. This line is not inside the plane because right here, it looks like it penetrates the plane and goes through the back. So this is a three-dimensional line. It's going in, and then right here, it punches through the paper, and it comes out the other side, which is why we see the dotted line. So I don't want to draw these two. As long as I've got the thing in the middle, we're doing fine and dandy. There's our sketch. Not bad. And now with each one of these, what I'm going to ask that you do is pause the video, give this a shot, and then let's kind of compare answers and see if you got something that's similar. You don't need the exact same thing, but you should have the same concepts down. So, number 5, I want you to try and sketch a plane and a line that intersects that plane at a point. Pause it, unpause it in a moment. Okay. So I need a plane, which means plane M. Got this going on. Well, now, we know with a plane that if I draw a line anywhere in that plane, it touches at many points. Here, 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 here. So all of these points that it touches in don't work. The only way I can get it to touch a line at one point is if I take my line and have it go through the plane. So how do I show that? Well, let's call this point A. And if it pierces it, it's going to come out the back. But down here, we'll be able to see it again. So if that's A, and this is B, I know that line goes right through my paper. Now yours might not look exactly like that, but you should have something that indicates a dotted line where my line pierces it. Why don't you try number 7? 3 rays with the initial point B and 3 endpoints, G, H, and J. 2 of them have to be opposite rays. Okay, now that you've had a shot to try that out, not bad. Rays with an initial point, B. Okay, so I need an endpoint G. If that's B, this is G. Let's call this H. Let's call this J. So 3 rays with endpoints G, H, and J, but 2 of them have to be opposite. As of right now, none of these are opposite, which means that one of them, I'm just going to have to make it opposite of the other. So that H, if I want it to be opposite J, I'm just going to move it vertical. Doesn't matter which one you move. But in essence, BH and BJ are opposites. There we go. Could have moved any other one, as long as you got that going on. Why don't you try number 9? Sketch 2 different lines that intersect a plane at the same point. Okay. Now that you've had a shot at it, this is going to be no different than we did on number 5. I'm going to sketch my plane. Let's call this plane M. And I know to intersect a plane with a line, as I just say, come down, pierce that plane, come out the back. There we go. We're going to call this point P for piercing. And we're going to call this line L. Well, if I want another line to pierce that same point, I'll just come at it from a different direction. So how about I come at it from over here, and then we see it pop out the back over there. I'll call this line, if that's L, I have M. Don't want to do N. Let's call this, oh, I already have a P. Yeah, let's just call it line R. So both of these lines pierce it at point P, and we see the fact that they touch the plane only at a single point because we see them come out the back. Number 11, probably one of the hardest ones that we have. We need to sketch two planes, M and N, that intersect at A, B. Okay, let's think about what that means. So if I have two planes, let's call this plane M. Let's call this plane N. Actually, they're capital, so I'm gonna whoop, whoop. Plane N and M that intersect at a line. Now, what you might be tempted to do is just go ahead and shove them together and say, boop, there we go, they touch at the line. We're gonna call this line AB. But remember, a plane goes in infinite directions. Our sketch, even though we show the edges, those edges are at infinity. So these planes can't touch at the infinite or the line of infinity. So I can't do that. Try a different orientation, but that didn't work. You might have the cool idea, well, how about I slide them over each other? But now they're parallel. They actually don't touch at all, because if I look at them from the side, these planes have just a little bit of a gap between them. So the only way that I can get these two planes to intersect is if we do something where, how about I bend them just a little bit? So if I'm looking at them from the side, I see that this plane and this plane intersect at, from this angle, it looks like at a single point, right there. But if I look at that from the side, awesome. That is a straight line. In fact, one of the things that I could do is if I take these two, I can show you that it's a straight line by forcing them to intersect at somewhere other than an edge. So let's cut a slit right here. Let's cut a slit right here. Let's have these planes intersect at the middle of themselves. Perfect. And so now I have my planes intersecting. And assuming that these intersect in a unique fashion, we see that that point of intersection right here is a straight line. It doesn't have any sort of volume to it. It's not a cylinder. But if I look at it, that is a straight line, and a straight line. Oop. Almost deseparated my planes there. So my two planes intersected a straight line. How do I draw that? Well, I'm just going to draw my first one, however I draw it. Let's call this plane M. And I'm going to attempt to draw, let's see, if this is going to be where I intersect. Ooh, I'm doing this in pen. I better do this well. Okay, let's go back. And then I'm going to cut over. Doing that at a hard angle, so I'm going to mimic the hard angle over here. Crap. So dotted lines, and then out front, come over. Now these are solid. What we can't see is we can't see this anymore, so this is now dotted. Because line M, or plane M, is behind my plane that's sticking out right there. Again, I should have drawn this in pencil, but too late now. And if that's plane M, I can call this plane N. And I'm going to intersect. I'm switching over to pencil here before anything else happens. Let's call this line AB. And I know AB goes out forever because it touches both ends of both planes, which are at infinity themselves. So there we go. Two planes that intersect along a straight line. A little difficult to draw, but we get the idea. And there we go.